Welcome to Networks Professionals.
Hello, everyone, and welcome to this explainer. Today, we're tackling something absolutely crucial. We're going to look at a concept that literally dictates how the modern world operates, which is working securely from anywhere. So, let's break down the technology that makes the flexible workplace possible, piece by piece, so you can see exactly what's going on behind the scenes. Okay, let's dive into this. We live in a world of telecommuters and traveling users, right? Whether you're at a coffee shop halfway across the globe or, just sitting in your pajamas at the kitchen table, you still need access to internal corporate files, complex databases, and proprietary apps. And you need it to work exactly as if you were sitting right there at your desk in the main office. But how do we actually pull that off safely? How do we extend the walls of the office across the world without exposing our sensitive data to anyone who happens to be looking? Section 1. The Remote Access Bridge. To really grasp this, we first need to understand the foundational concept of how this remote connection actually functions. Now, what's really interesting about this slide is the physical analogy here. A remote access VPN basically establishes a secure, encrypted tunnel directly over the public internet. Think of it like carving a private, armored transit route right through the middle of a totally chaotic, open public network. It safely connects you, the remote employee, directly to the private corporate network, completely shielding your data from all the outside noise. Think of it like this. On one side, you've got the Wild West of the public internet. It's unsecured, it's open, and frankly, it's potentially full of threats. But on the other side, you have your highly secure private corporate network, which is holding all the good stuff, your critical internal files, databases, and applications. The VPN acts as the vital bridge between these two incredibly contrasting environments. It makes sure that as a user crosses over from the public domain into the safe haven of the corporate network, they are entirely protected. Moving right along to Section 2, how the architecture works. We're going to shift gears here and dissect the mechanics of the system, looking at how the software and the security actually operate under the hood. The physical architecture is actually beautifully straightforward. The connection always relies on two critical points. Step 1 happens wherever you are. It starts with a client application that you install directly on your laptop, tablet, or phone. Step 2 happens back at headquarters, ending at a centralized corporate gateway. These two components basically reach out, shake hands, and boom, they establish that secure tunnel. And this brilliantly illustrates that it's not enough to just build a tunnel. You have to fortify it. To ensure that tunnel remains completely impenetrable once it's set up, the architecture relies on three foundational pillars. We're talking secure encryption, authentication coupled with MFA, and strict policy enforcement. Let's break each of these down. First up is secure encryption, relying on standard protocols like IPsec and SSL/TLS. Don't let the jargon intimidate you. What this actually means in practice is that the transmitted data is completely scrambled. So even if some bad actor manages to intercept the data packets while they traverse the public internet, all they're going to see is just an unreadable mathematical mess. This encryption absolutely prevents any meaningful interception. So the crucial point is, you can have the strongest tunnel in the world, but if you let the wrong person in, it's totally useless. In fact, compromised credentials are the leading cause of network breaches globally. Crazy, right? That's why the gateway demands secure user verification before any access is granted. It needs to verify exactly who is knocking at the door. This ranges from standard credentials and digital certificates stored on your device, all the way to multi-factor authentication, or MFA, which demands a secondary dynamic proof of identity. That brings us to our third pillar, policy enforcement, which relies heavily on identity and role-based access. You see, once someone is verified and inside the tunnel, they don't just automatically get the keys to the entire kingdom. The system restricts user access so individuals only reach their approved network segments. For example, a salesperson shouldn't automatically have access to the HR payroll databases. This enforcement ensures users are limited strictly based on their specific identity and their job role. Now, of course, most organizations aren't out there building these complex infrastructures from scratch. They rely on common, trusted industry solutions to build their secure tunnels. Tools like OpenVPN, ExpressVPN, and NordVPN teams do a lot of the heavy lifting to provide both those robust client applications and the reliable gateway infrastructure. Let's move to and see how this builds into the everyday user experience. Organizations will often configure these VPN solutions to integrate seamlessly with their existing identity providers, Active Directory being a prime example. By doing this, they create a super smooth, secure single sign-on, or SSO experience. The user just signs in securely one single time, The VPN authenticates them with the identity provider, and they get smooth access to everything they're authorized to see without having to juggle dozens of different passwords. Okay, let's wrap things up with Section 3, Evaluating Your Organization's Needs. Let's switch into consultative mode for a second. If you're evaluating options for your own organization, there are a few things you really need to consider. First, you've got to ask yourself, how many remote users actually need to connect simultaneously? This is vital because it totally dictates the required scale and bandwidth of your centralized gateway. I mean, if you only have 5 people traveling at a time, your networking needs are vastly different than if an entire workforce of, say, 5,000 people suddenly needs to log in from home on a Monday morning. Here's your second critical evaluation question. Do you need to protect Windows, macOS, or mobile endpoints? Remember step 1 of the architecture, the client application. You have to ensure device compatibility for that app. If your company issues MacBooks and iPhones, well, a VPN solution that heavily favors Windows just isn't going to cut it. You have to know exactly what endpoints you are protecting. And the third question to ask, are you hosting resources on-premise, in the cloud, or both? You really need to think about where your private corporate network actually lives today. If all your databases are sitting in a physical office building, the tunnel just routes there. But if your applications are up in the cloud, or maybe split between the two, your VPN gateway needs to be perfectly positioned to route that remote traffic efficiently to the correct destination. Which brings us to the most critical question of all. Is your organization truly prepared to secure the tunnel for your remote workforce? We've explored the bridges, the encryption, and the strict access policies. But having the tools is only half the battle. Are your current endpoints the strongest link in your chain or the weakest? I really hope this explainer has given you the framework you need to assess your own network security. Keep learning, keep evaluating, and we will see you next time.
Thanks for watching.